Hi, in this video I will talk a bit and show tools that are needed for building bicycle wheels or for wheel building. I have indirectly showed those tools in my videos where I was showing how to build wheels, but here I will show the tools in detail and explain what are the pros and cons of different types and how they are used and so on. So I will probably try to make a website article about this as well, because at least for me it's easier to just see the pictures and read, but some people prefer to see video and to see how they look like when they are moved and used. So I'll try to do that here, and as always you will have to put up with my Tarzan English and all the noises in the background and my pauses while I think about how to say things in English. So we can now move the camera to show the tools and start. Okay, these are all the tools. To people who are like me, this is fun, nice and exciting, and for some people this might look a bit scary, intimidating, but to use an analogy, if we packed our things for a weekend trip and put them all on a bed, what we are planning to pack, and showed that to some person from, I don't know, some Amazon tribe who don't wear anything from clothes a lot, well, it would also seem very confusing. What are the spare t-shirts, socks, toothbrush, toothpaste, what do you do with that? And this is the same. When you understand how it is used and what it is used for, it's fine, it's logical and nothing to be afraid of. And I will show now and explain all the tools in some order of importance, in my opinion at least. So the first thing that we need, the basic tool, is a spoke key. You cannot generally build wheels without a spoke key. You have to be very inventive, okay, of course. There are no limits, but this helps a lot. And this is a basic model of a spoke key that I think is probably the best design. Why do I think so? Because it catches the nipple on 4 sides. It just has a little slit here so that you can put it over a spoke and then slide it, sorry, wrong way, trying to catch it, then slide it over the nipple, trying to show it on camera, okay, like this. And you can see that it engages all the sides of the nipple, so there's minimal probability of causing any damage to the nipple when you get to the high tensions, whether you are tightening or loosening spokes to rebuild the wheel or replace a rim or something. So this is the best design. I will show now another model. This is what it looks like. It catches the nipple on 2 sides alone. So this is inferior. I would avoid any sort of spoke keys that are designed like this unless I have no other option. Another thing, this is like a universal, which brings us to the topic of sizes of the nipples. This one is for 3.3 millimeter ones, like this nipple. But it also has only 2 sides, so I would avoid using these tools. But when it comes to the sizes, most nipples made by Sapim and DT Swiss are 3.3 millimeters, at least in my experience. And the next most common size that I come across are 3.45 millimeters. And I don't know the US sizes in those gauges, 13, 14 gauge or something like that. I'm very sorry, blame the French. These are those keys. This one is for 3.45 and this one is for 3.3 millimeters. And I build most wheels with these two. These are most commonly used. There are many exotic, because industry tries to make more money by reinventing the wheels. So this is for, I think, Mavic spokes, but don't take my word for it. I would have to check. I don't remember why I had to buy this one, but I had to buy for one wheel at least. And there are 2 sizes, and it doesn't look bad in terms of engagement, but it's very exotic and complicates things. So, but if you have the nipples like this, you have to get the proper tool. So that allows us to tighten the spokes and true wheels. The next thing we need is either a truing stand, or we can use the frame of the bicycle as a truing stand by using forks or on the rear side on those chainstays, tightening a zip tie and letting one part of the zip tie go a bit out and cut it to size and use that as a reference, or even brake pads if you have rim brakes. All that can be used to build wheels, and it just makes it a bit less convenient and less fast, but you can build it. I've used that with success. Now, in order to screw in a nipple onto a spoke, when we have double-walled rims like this one, we don't want to lose the nipple to fall inside of this wall and then to try to fish it out. So we will use a trick. This is the cheap, simple solution. You take one of these for hygiene. I don't know what they're called in English, but you can see what they look like. And just cut it at an angle with a knife, and you get something like this. So you can take a nipple, and it holds it. Not very well. Yeah, it's not perfect, but it works. So it holds a nipple, and then you can insert it into the rim and onto the spoke that is on the inside. There. Okay, you get the idea. And you get the idea why I don't really like this method. This is used a lot. I should make a new one because it does no longer hold the nipples very well. Alternative option is to take I prefer this, to take a spoke and thread on a nipple so that the spoke protrudes out, then use just some crimpers to press the nipple and deform it so it doesn't turn around. And you can also put some thread locker onto the threads to glue it in place. And I've made the handle and also this to make it easier to turn, and then you can just screw the nipple and use it to put it into the rim. Okay, that is another option. And this is a bit more professional looking one. This is made by Junior. I will list all the tools shown here with links when I find the time. But this is how it works. It has this like a spring to hold the nipple in place, and it has these notches to prevent the nipple from turning when you're screwing it in. So this is very, very helpful tool, and I usually mostly use this one. Now, after we have laced our wheel, we need to get it started. For that, I have made this tool. It's like a screwdriver, flathead 6mm one. In this particular case, that is the width of this section. This is across 6mm wide. It fits nicely, and I've ground it down so that this sort of pin, or what do you call it, is exactly 3mm. And that's perfect for building wheels because it allows me to start screwing in a nipple. Let's make this. I can start screwing it in. I hold it with my finger to provide some sort of pressure and just resistance, not pressure. And then when this gets pushed out, this tip gets pushed out by the spoke, when the nipple is screwed in by exactly 3mm. I hold my finger to put some resistance, because otherwise it can turn just by friction if you move it sideways, and you get half a turn, sometimes more than it's more than the exactly 3mm. So it's safer to just use a finger and make sure to hold this in parallel to the spoke, to not twist it aside. But when you put some resistance, it's usually even that does not make too much problems, but you should pay attention. And That's how you start the wheel, with all the nipples screwed in to exactly the same amount, as much as possible, so you don't have too many problems later on. You just increase the tension, you don't have to straighten the rim too much. Okay, another important tool that comes in now is this. It's like that paper tape for that is adhesive, and it's important because you will get interrupted and you need to mark where you have stopped, and if you don't have this on hand, you will regret it sooner or later. So remember this. And then we need to make sure that all the spokes on one side of the rim are of the equal tension relative to the others on the same side. Yeah, I'm not sure how well I explained this. Anyway, so you can use a plug, and when the wheel is in a truing stand, you can just plug the spokes near the nipples. The ones who have higher tension will make more higher pitched sound, and the ones who are loose like these make this blunt sound. Just make sure to not put your hand on different places, because that will alter the sound pitch. You don't want to make your measuring errors, so always use the same hand position relative to the spoke you are testing. For me, this is very slow. I'm not very good on when it comes to tones in music, unfortunately. And anyway, this is a more precise way of measuring spoke tensions. And here is how it works. It measures the deflection of the spoke when this spring loads it. So this spoke is loose. It's out of scale. It won't show anything. It's like makes 2 turns. But if this spoke were at, let's say, 80 kilopond, this is what we would measure, something about this. If it's tighter or looser, the measurement would show it. It's the scale is exponential, but we won't get into that. Now, this was designed by, I'm not sure how to pronounce his name properly, Jobst Brandt. I will write it down in the video description, and it's not a protected patent. Everyone is free to make this one, which is a great contribution to the human knowledge and engineering. But spoke tension manufacturers who make spoke tension tools, very few make these models for some reason, and the other ones, especially, I will note just models from Park Tools or Unior even, or DT Swiss. They are, how do I say, they're designed so that they are imprecise, not just inaccurate, but imprecise. So they don't, by design, they are not very likely to always give the same reading for the same tension. I awfully explained this probably, but for some reason this is probably more expensive to build, because this measuring tool, not sure how to call it in English, costs a lot, and manufacturers put a lot of money into marketing and not a lot of money in design and production, in my opinion. So they prefer to make something that's cheap to produce and sell it for a lot of money, and rather than making something that's of high quality, because then with the markup it would cost hundreds of dollars, as this costs in the US now, I think. So the advantage of using a spoke tension meter is that it allows you to do it more simply. It's simpler and faster than listening to the tones, at least for me. And another thing is that it allows you to see the total tension of the whole spokes combined, so that you don't overstress the rim over its total tension it can take, because then the wheel could buckle or you could have some problems. With the aluminum thin-walled rims and steel ones, it's not too much of a problem. You just put it a notch back, the tension, unscrew the nipples by half a turn and then through it, and it's okay. But with some carbon fiber rims or double-walled aluminum ones, you could deform them perhaps permanently. Plastic deformation causing it. So this is probably faster and safer to use, but I must say that I have managed to build wheels using only this and using my hand feel to compare properly built wheels to see how tight those spokes feel and compare it to what I'm building. And later when I check with a tool like this, I could confirm that all the spokes were of, how do I say, acceptably uniform tension, and the total tension was also within the limits of the optimal tension for the rim. So it's not necessary, but it helps a lot. Finally, a good pair of gloves with thick lining. This helps when you stress relieve the spokes after during the wheel build phases and when you're finished, which is very important. It boils down to squeezing the pairs of parallel spokes very hard, and when you do this with your bare hands it's very uncomfortable, but you could also probably injure your tendons because a very small area is putting a lot of force on your palms, and you also using the force to squeeze it strongly. So I don't think it's smart to do it without gloves. Maybe doctors will correct me if I'm wrong. It's definitely more comfortable. Okay, I hope I've explained properly the basics of bicycle wheel building tools, and I will include all the important links in the video description with links to tools when I find the time and when I remember, and perhaps some articles of mine that explain this topic. And that's it. Thank you for watching, and cheers.